Hey guys, welcome. So today is an important day at Nomic.
Nomic.
Startup that recently announced a $17 million investment.
The original inspiration was like, let's just make a sick open source model that everyone can use and, show people how to do science, right?
This is fully open source. The data set is open source. The code is open source.
Looking at the project, you felt like an overnight success.
With over 33,000 stars on GitHub, a really impressive project.
The version of the world that I fear most, 2 or 3 mega companies lock everything down in like the early days. The effort payoff curve, it's not just NVIDIA GPUs.
Oh, there you go. VC money actually helping.
Our sales funnel is literally like Twitter to Discord to enterprise sale. A key part of what made GPT-4All so good is we had spent the last year building Atlas.
Nomic Atlas, visualization of embeddings,
enables you to store, update, and organize multi-million point data sets of unstructured text, images, and embeddings.
Hey guys, welcome. So today is an important day at Nomic because you are releasing a new product, which I'm excited to talk about in a little bit in the second half of this conversation. And I'm also grateful that you chose the MAD podcast to talk about the offering on the day of the launch. I think thanks to you, we've officially graduated to being a news organization. So thank you for that. But I'd love to start from the top and talk about you guys. What is your personal journeys and your journey to Nomic AI?
Yeah, so hey everyone, my name is Brandon. I am the co-founder and CEO here at Nomic AI.
I'm Zach. I'm a ML engineer at Nomic.
And, I really got started with Nomic just based on some experiences that I had at, several previous roles. I had been a machine learning engineer in several different kind of verticals, be it robotics, defense, medicine, finance. And I had started seeing kind of the same problems over and over again. A lot of the issues, revolving around kind of data quality and how that affects kind of like the downstream properties of the models. And when you're working in these domains that are, like defense and medicine and finance, where it's like super high impact and you really have a vested interest in your models being right, you start to learn very quickly that a lot of the utility that these models can provide is unlocked if you spend a lot of time really curating your data sets. And so the reason that I ended up deciding to start Nomic with my co-founder, who actually worked at me at the previous role at RAD.ai, which is a generative medical startup that was shipping transformers on radiology text back in 2018, was because we saw how impactful really, upping the data quality in these products could be. And so we started that journey together, and then we're fortunate enough to run into Zach through some open source work, and I'll let him tell that story.
Yeah, so I came across Nomic and Brandon and Andre at this VC fund's, open office. So I worked out of there. I was working at a biotech startup, and I first came across Atlas, and I was super intrigued by it because I had been trying to train some models on basically DNA sequences. And I didn't have a great way of evaluating it. And I just wanted to see like, okay, what does my data look like? And PCA wasn't working just because it would take too long. So that was my first introduction. We started hanging out every now and then, talking about ML, kind of bouncing ideas off of each other. And on the side, I'd been doing a little bit of open source work in some discords with Luther and Carper. One weekend, Andre comes to me. He's like, I think there's a really unique opportunity here. Like, we'd love to train this model. We have all this data for it, but I don't have the time. Being, the co-founder of a 3-person company, your time's incredibly limited. Was a little bit bored. I think my girlfriend was out of town that weekend, and I had some extra time. So I was just like, I'll spend some time and train this model if you guys pay for the compute. So it worked out well. And I think I joined Nomic, I want to say like 3 or 4 weeks later. But yeah, it was kind of, right place, right time.
Great, excellent. And Brandon, if I remember correctly, you had NYU, right? You were doing a PhD at the time you were starting Nomic. Is that right? Did you drop out of it, or what was the story there?
This is my co-founder, Andre. Yeah. I actually, funny enough, I actually also dropped out of a PhD to join the radiology startup where we met. So, we like to joke that, yeah.
I think that's a really interesting. It's a really interesting pattern that I've seen across many founders to be PhD dropouts. So meaning having the fundamental intellectual caliber and intellectual curiosity of doing a PhD, but not the patience of lasting the whole way until completion of the PhD. It's a very interesting heuristic.
Well, that's exactly it. It's the two big factors for me, and this is going to be I guess, tangent now, but the two big factors for me were velocity and impact. Really, like when I ended up leaving Hopkins to join Rad AI, the reason that happened is one of the co-founders of Rad AI sat me down and was like, "Look, like I'm sure your thesis is great, and all four people that like know what a latent structure model of a random dot product graph is are going to love it." But if you want to, actually come here and like ship code that is going to like help radiologists, and like be deployed in clinical practice like a week later, now is the time. And we have the GPUs, and that's pretty compelling. And even nowadays, like it's increasingly hard to get those GPUs in academic positions, and so it's making increasing amounts of sense for I think the flight that we're seeing from academia to industry.
So for a while, that was you and Andrew.
Andre, yeah.
Andre, and so I remember you guys burst onto the scene with GPT for All, which I remember like felt from the perspective of an outside person looking at the project. It felt like an overnight success and just like crazy open source traction, and that was a weekend project, right? Wasn't it? Like, what was the story there?
I mean, that's the model that Zach was talking about training. And it's also funny how everything can look like an overnight success kind of from the outside, but I think a key part of what made GPT for All so good is we had spent the last year building Atlas, and it was the first time we really applied Atlas to the task of like cleaning training data for a model. And so, within a weekend, we could go in and like, if you look at the original GPT for All paper, we show like, oh, here's how you identify like the sections of the training data where the model's refusing to respond. And, like here's where you identify the parts of the training data where the model's giving one-word answers. And like, obviously you want to remove those so the model that you're training doesn't learn those behaviors. And so it's one of those things where, which I think is so true in startups, where like the effort payoff curve is super nonlinear. It's like very much like a series of step functions where you put in all this effort and then only when you pass some threshold, your payoff shoots up.
So you're saying that it was not as easy as it looks like. That's a surprise.
Fortune favors the prepared is what I'm saying.
Yeah. Exactly. So, having said that, why do you think that was so successful? Was there like just, I think Zach, you mentioned right place, right time about your journey into the company, but was that true of GPT for All as well? It just like hit the right kind of crowd at the right time, or was there like any lesson that one could derive from the success?
Yeah, I think for me, the thing that stood out to me, I think after the fact made a lot of sense was that at the time it was really hard to run these models if you didn't have the compute to. So one of the things that Andre really advocated for while we were training the model was like, okay, we should get this quantized and be able to run on computers that most people have or a lot of people have. I was originally against it. I was like, this isn't that interesting. Like, I don't care. But it turns out he was right. I think the access part of it was the bigger part versus the actual model itself. Like the model itself, at the end of the day, like somebody tried a better model in, like the next week or the next month or something. And there's been many iterations of the model, but it was more so like the access of it, and having models on your computer where people who care about privacy, I think really helped shine through there.
Great, and maybe as a level set to make this interesting for everyone. So, what was ChatGPT for All? What was the concept of the product? What did it do, or the model?
Yeah, so it started as basically just a reaction to GPT-4 becoming increasingly closed source. We, as a company full of like people that basically met through open source and like have been open source contributors through our careers, we're like pretty frustrated with the fact that like this, quote unquote open lab was like, yeah, we're not going to tell you anything about the data. We're not going to tell you anything about the training. And we'll get into this later when we're talking about benchmarking, closed versus open models. But it was born out of that frustration, I think. And so the original inspiration was like, let's just make a sick open source model that everyone can use and, show people how to do science right. But really what it grew into now is sort of this like incredible open source ecosystem where you have these, all these companies around the world now shipping models in the open source. Like Mistral's doing really awesome work there. Hugging Face is doing really awesome work there. Replic's doing really awesome work there. And we're now part of this kind of weird kind of almost emergent like assemblage of like hackers and like hobbyists that are like taking these models and like running around and quantizing them, or like actually training or like slurping new models in the open source. And we sit at this junction now where we help to ensure that those models can run on a wide variety of different hardware, so that no matter what computer you have access to, you can run the models. And we make sure that you can actually do retrieval augmented generation, which we'll talk more about later, on these models in a very easy way. So in sort of like this sort of drag and drop interface. And so really just doubling down on the accessibility portions of this that I think made the GPT for All project such a success in the first place.
And maybe for the dumb VCs in the room, do you want to explain what quantizing means? Is that compression effectively?
Yeah, it's effectively taking the weights of a large model, reducing the precision on them, just basically taking the weights, making these numbers smaller so that you can actually load the model into your computer. Just because if you didn't do that, your computer would effectively blow up. I remember trying to run this when we first started doing my computer. I had an older MacBook, and at the time it was just barely fitting into RAM, and it was on fire. But now with like the newer MacBooks, it's a lot easier to run these with the new Apple Silicon.
So to drive this home, so GPT-4 is now a family of models. So that could be Falcon, that could be other things, and the common point is that you've quantized all of them. So all of them are now small enough to be run locally. That's the common characteristic of what you did across all the models.
That's right. So I think the most popular model right now is Mistral 7B, quantized to 4-bit precision, fine-tuned on the OpenORCA dataset. And one of the things, there's two key factors that I really want to, drive home is the contributions here. One is making sure that those models run as fast as possible across a wide variety of pieces of hardware. So it's not just NVIDIA GPUs. Like if you have an AMD GPU, if you're running Metal, if you only have a CPU machine, like you should be able to run as fast as possible in all of those situations. And also making retrieval augmented generation easy. So if you want to personalize these models on your machine, that should be as easy as dragging the files that you want the model to have access to into a folder. And so those, I think, are the two really, really big kind of value adds of GPT for All right now.
I know what you said a minute ago about this like collective of hackers, or I forget the exact word to use, but that was great. The open source AI world right now seems to be just completely exploding and super exciting. Like, is that like for you guys who are like deeply into the space? Is that the same impression as like the rest of us? Like, what's your overall sense of the health and vibrancy of the open source AI ecosystem?
Yeah, it's all-time highs, I would say right now. Like we've got a ton of VC money flowing in the companies that are shipping things open source. So like, I love that that's happening. I love that, I think on a podcast right after GPT for All came out, I think it was the Weights and Biases podcast with Lucas, I said something like the biggest challenge for open source is going to be getting like the monetary resources to do like a 7 billion model or, these bigger models. And so it's amazing to see companies like Mistral actually going and like doing what they say they're going to do and releasing these amazing models. And, Meta as well with the release of Llama, I think has played a big part here. And I think also one of the reasons it's, kind of popping off right now is we really are at this kind of new frontier in terms of the discovery of what these things can do. And so it's totally possible that, some random person, in the middle of nowhere that's just like somewhat interested in this stuff, spends enough time poking at it. There's so much new stuff to find that they can discover things that are really amazing. And so you see some of these really incredible techniques coming out of, not maybe what you might call like the royal science or like the universities, but some random person will be like, oh, hey, like I did this, new type of interpolation between these two model weights, and it turns out it gets way better, or, things like this, or, oh, I happen to have gone and curated this data set that is now like incredibly useful for fine tuning towards, XYZ task. These things are things that like a single person can do on commodity hardware that really move the needle now. And so I think now that there's attention on it, and because it's such an inflection point in terms of what is possible with the technology. People are really, able to do a lot without needing access to a ton of resources. So,
oh, there you go. VC money actually helping. Who knew? So you all have a relationship with Llama CPP. Do you want to talk to that?
Yeah. So this has been, as Zach was talking about earlier, one of the biggest parts I think that was integral to the success of the original GPT for all is that it was quantized. We use Llama CPP for that, and I think one of the things that we've been really proud of here at Nomic is the fact that we've been able to actually bring staff on full time to work on things like improving Llama CPP. And so, right now we have Nomic staff working back and forth with Gergi on, getting new compute backends merged in to improve the, support for these models across a wide variety of hardware. And I think the lesson here for the broader open source ecosystem is as economic pressures start to apply and the VC money starts to run a little bit drier, staying collaborative and making sure that, as a whole, the open source ecosystem itself continues to be able to move forward. And if someone else's repo is one that's useful, in your project, being open to collaborating with them and being flexible about where those boundaries lie is really, really important. And so that I think is a lesson that I really hope all of the people building an open source right now take to heart.
Okay, excellent. So that's GPT for all. But as you mentioned, there was actually a product before GPT for all called Atlas. What does that do?
Yeah, so Atlas is a tool for exploring and interacting with massive unstructured data sets using only a web browser. It was born out of a lot of the work that my co-founder Andre and I were doing at this, radiology generative AI startup, Rad AI, where a lot of the work on the models involved exploring these massive data sets, finding places where maybe the doctors had made mistakes or the model had made mistakes, looking for patterns in those errors, attributing that back to the training data, looking for distribution shifts in the actual production data. When we were at Rad AI, there was this super interesting global health event called COVID. You may have heard of it. That happened. That was this massive distribution shift in our query stream, and having at the time we didn't have the tooling like Atlas to deal with that in sort of a very flexible way, and it caused a lot of headaches, certainly. And so effectively the interface that we sort of converged on is what would be ideal for this is this sort of massive scatter plot that you can run in your web browser, where every piece of data in your data set is a point, and two points are close together if the pieces of data are similar. And what we found is this sort of layout is particularly useful for debugging AI models because their errors tend to pop up in localized regions of it. So we're actually doing a collaboration with Hugging Face recently on their open source IDEFIX model, looking at where that model performs systematically well and systematically poorly, and all of the places in the latent space, in the sort of representation space that we're showing people, where the model was performing poorly, were all kind of spatially localized. They popped up as little patches of land in the data, and similarly, all the places where maybe the model was even memorizing data popped up as these little patches, and that was incredibly informative for us in terms of detecting bad data, detecting not safe for work data that should have been removed, detecting data that was misextracted, detecting things the model was memorizing, or detecting, categories of data that the model was, biased towards reproducing, things it did particularly well on. So that is sort of, a broad motivation from the ML engineering perspective of how Atlas got started.
Great. And bearing in mind that you're a young startup and in a super fast moving industry, how does that all work? Those two pieces, how do they work together, including from a go-to-market perspective? Because GPT for all presumably is more of a developer audience. Is Atlas more of a kind of enterprise audience? Is Hugging Face an enterprise customer for you?
Yeah, so Atlas is definitely a B2B enterprise tool. We make it, we have very generous limits for individuals like power users, academics as well, especially to make it so that they can leverage it. But it is kind of the core growth engine behind the monetization of Nomic. And I think that puts us in a really, really interesting position relative to a lot of other open source companies, because it means that we can keep GPT for all as this very pure, love letter to the community open source sort of project. and we won't sort of be pressured to eventually find a way to kind of like squeeze it for dollars. But I think the two interact also very well from a funnel standpoint. So the kind of person that is interested in tooling to help them understand and curate massive unstructured data sets is the kind of person that's either one, using that to train models, or two, generating a lot of that kind of data. And that's exactly the kind of person that is interested in tools like GPT for all. And so, a lot of the, first enterprise sales that we had with Atlas were inbound in the GPT for all Discord. And that's, maybe this is just what building a company in 2024 is, but our sales funnel is literally like Twitter to Discord to enterprise sale. It's insane.
Any lessons learned there from a go-to-market perspective? Is that just generally comparable as selling developer tools, meaning you need to be authentic and you need to be responsive? What have you learned?
Yeah, so I think one of the most interesting things I've learned was be open to your thesis about core audience shifting. So when I originally built, and envisioned Atlas, and sort of brought it to Andre and the team to help me realize it, I very much thought that the ICP, ideal customer profile, would be a machine learning engineer. And a lot of our early users were machine learning engineers. We still have a lot of them using the system. But something that struck me as very interesting is Atlas started to get picked up by a lot more kind of like, I don't want to say less technical teams, but an archetype that's more of a business analyst or someone doing business intelligence, where we see, consulting companies that get these data sets from their customers, and maybe they have domain expertise, but they can't code. And so never before have they been able to interact with this data with this level of velocity and this level of granularity. And so we've seen, a much wider adoption in terms of how technical the actual users of the systems are than I originally anticipated, which has been really, really interesting to see.
All right, I think we've come to the moment of the conversation where we are going to talk about the drumroll new offering launched today. So what is it?
Yeah, so we're launching Nomic Embed. It is the first open source, reproducible, long context text embedder that beats OpenAI Ada as well. We are releasing the model weights, the training code to replicate the model, as well as the training data. And I think this is something that's near and dear to my heart, as I spent the last, few months kind of painfully going through all the data, curating it, searching for needles in a haystack in papers and at the edges of GitHub. So really excited to get this in the hands of people and see how they use it.
All right, very cool. Congratulations. So maybe as a refresher for everyone on listening to this, what is an embedding model?
Yeah, so I think the way that I like to think about it is an embedding model is a function of semantic meaning in English or whatever language to semantic meaning to computers, and it's becoming increasingly important for AI applications now, especially retrieval augmented generation, which helps update basically models without having to retrain them. So you can augment pre-trained models with new information, which obviously is very useful and less expensive than having to retrain it yourself.
So to play back, it's effectively translating text and unstructured data into the kind of like numbers that machine learning models can understand and digest.
Yes, correct.
And what has happened to this whole space? So it's interesting. Maybe call it a year ago now, I was like having this kind of conversation with vector database founders and CEOs, and it was very much presented as a kind of a solved problem and something that was like, you need this thing at a moment to input data into the vector database, but it's no big deal kind of thing. And it seems like over the last few months, it's become like a huge area of activity and with a lot of people competing. So what happened to that space?
Yeah, I think, the fundamental thing here is people realize that there's like a new data primitive, and that data primitive is here to stay. And that's the vector, the embedding. And, just to bring this back to Atlas for a second, in the same way that we see vector databases taking that new data primitive and trying to play out the implications of that at the database layer of the stack, I think we're going to see, a radical shift like that at all layers of the business software stack. And the current conception of, what I believe Atlas to be in the limit is the logical extension of what happens when you make, embedding vectors a fundamental primitive at the sort of visualization or business analysis, business intelligence level of the stack. So internally, we love to throw around calling it sort of like a Tableau for unstructured data.
So maybe you mentioned OpenAI Ada. Maybe like paint a quick picture of the space. Like, what are the other embedding models that either have existed for a while or are just coming up?
Yeah. So roughly in this space, there in the open source side of things, there's a bunch of really great models that have been released. The model weights have been released, and a few of them are being hosted on embedding endpoints. But the problem with a lot of these models is that they have a small context length, so they're limited to 512 tokens, which I think nets out to maybe a few paragraphs, which becomes a problem when you have large documents. Maybe you have like long financial documents and you want to reason over the whole document versus chunks, just because it gets a little confusing and it's a little hard to reason about like the right way to chunk up a large document if you need to like recall something from the first paragraph in the last paragraph. So that's the open source side of things. There's one or two long context models. The ones that are good are either too big, they're in like the 7 billion parameter range, or they don't actually beat OpenAI Ada's model. And then, for the long context on the closed source, Ada is, kind of the de facto for many people's applications today. But with closed source, the big problem is you have no idea what data they've trained on, and you kind of have no auditability on what's going on with the data, the training, basically anything that's going on under the hood. So this is kind of the gap that we're filling of an open source version of Ada that outperforms it on a few benchmarks. And full auditability.
Embeddings are super important also because they're part of this, I guess, process called RAG that a lot of people are now becoming familiar with. Do you want to maybe re-explain quickly what RAG is and how embedding fits in?
Yeah. So to me, RAG there's three main components to RAG. It's the embedding model, a language model, and a vector database. So the way that I like to think about it is if you have, a collection of documents, say it's Wikipedia, and you want to ask a bunch of questions about it, but you don't want to actually read every document, what you can do is you first embed all the documents of Wikipedia using the text embedder, store them in the vector database, and then you can start to ask questions about your documents. So if you wanted to ask, where was Beethoven born? You would take that question, you would embed that question, get the nearest or basically most similar documents to that question, and then pass those documents to your language model, where your language model can then reason over and answer your question given sufficient documents. So basically, you're treating your language model as a reasoner versus like a lossy database.
What are some technical details that you learn while building this new model?
Yeah, I mean, it's, I think, a boring answer, but it is data. It really makes or breaks your model. There's a lot of times where we're trying all these fancy tricks. And, at the end of the day, we uploaded some data to Atlas and we're like, wow, this data is crap. This doesn't make any sense. So I think that data auditability, like we said a few times now, just understanding what's going into your model, making sure that it makes sense to you as a human, I think, gets you most of the way there. And I think that's like one of the bigger points that I've had to relearn over and over again in every project that I do.
And so I think also, one of the things that I'm most proud of that we're able to do with this, which is distinct from a lot of other, open source releases, is we're not just releasing the model weights, we're releasing the data set that Zach spent all of his time curating. And what this is going to do is it's going to allow people that want to build upon and adapt the model to, one, be able to reproduce it, and two, be able to start tweaking it and, learning for themselves without having to go through that arduous process. And as far as we're aware, none of the other, top models on any of these benchmarks have gone out and released their data sets. Most of the time we just see open weights. Sometimes we see a code base, but you almost never see the data set. So we're really proud that we're sort of delivering the full end-to-end package to the open source community.
Yeah, that's awesome. Why do you think why don't people do that? Is that like a reproducibility kind of like issue? Is that what is it? Is that marketing? Is that coming across as open source but not being very open source?
There's a couple answers here. I think the truest answer is that the data is often the secret sauce. Like when people talk about like, oh, what is the secret sauce of your AI model? It's almost always the data. Sometimes it's like clever scaling, and you'll have architectural tricks that move the needle, but like almost always it's the data. And so, if a company wants to appear open source without maybe really being open source, they'll release the weights, but not the data. For some companies, that we're now seeing, you're seeing like Voyage pop up, for instance, and Cohere is another one that are really like investing heavily into like embeddings as a service. That's their IP. That's their core IP. And so, for their business to work, they can't release it. But then you start to get into these like very weird conflict of interest scenarios where it's like, okay, but if they don't release it, one, like, there's an auditability question on that model. And then there's another question, which is, if they don't release the data and they don't have necessarily the tooling to actually comb through all of it, it's really hard to make sense of if the benchmark scores that they get are like super legit or not. Like maybe they're legit, but like you can't actually check, right? And so I think that's an element to it as well, perhaps.
How does a current benchmarking system work to that point, and compared to like closed source in particular?
Yeah, so with respect to the embedding models, there's this benchmark called MTEB. I think it's called like the Massive Text Embedding Benchmark, and it comprises of a few different tasks. So classification, retrieval, which is kind of ties back to the retrieval augmented generation point, clustering. How close can you get the embeddings of related documents together, and like exclude any false positives, and a few other tasks. It's really helped, I think, improve the field a bunch. But with any benchmark, I think once you start measuring it, it quickly becomes a game of like, how can we make this number go higher without with some maybe questionable tactics on how to make that number go higher. That's on the, I guess, general embeddings, like how good are your embeddings? Since most of these models don't have a long context, there aren't a ton of benchmarks, but there recently have been 2 long context benchmarks that have been released. One, I think, was released in, I want to say, October by Gina AI, comprises of 4 data sets. And then recently, Hazy Research from Stanford released a long context benchmark called LOCO. So those were the 3 that we focused on and compared against some of the other long context models.
Okay, very cool. So congratulations again on the launch. So as a result of that, so you're now a 3 product company, product/models. You got Atlas, you got GPT for all, and you got Nomic Embed. So how does that fit in, especially the latter part? We talked about the other 2 from a go-to-market perspective a bit earlier, but like how does that latter part fit into the overall go-to-market model?
Yeah, so one of the key portions of the Atlas pipeline is actually embedding all of your data. And so one of the things that we're excited to start doing is like, as we build up this, core competency of building, these incredible embedding models, we can release them to the public and also incorporate them to improve the Atlas system. And so there's sort of direct product value and sort of direct auditability on the Atlas side of things that I think is really important. And beyond that, going back to, if you want to talk about go-to-market and how GPT for all fits into that, this idea of if we can do these things where we're really just like giving as many people as possible access to this technology, be it, what you need for retrieval augmented generation with Nomic Embed, or what you need to actually get up and running with the generative models themselves with GPT for all, regardless of your hardware, that's just going to bring more people into the AI ecosystem faster. And I think that demand sort of directly translates to, need and sort of like usage of Atlas. Because again, as people are producing massive unstructured data sets and consuming massive unstructured data sets and tweaking these models and, really starting to learn the lessons that, we constantly relearn, which is like, it is literally always the data. If something is wrong, it's almost always the data. Understanding that having tooling to really dive into your data and understand it at an incredibly detailed level is just going to proliferate more widely.
And so what's the, both roadmap / vision for the company? Like fast forward a couple of years or 3 years, is the idea that you guys are going to be very prolific in releasing new products based on where the market is going? And then what's the end result? Is it like a suite of different products that you're going to integrate into some kind of platform? Like, how do you think about it?
Yeah, it goes back to the core mission of Nomic. Our objective function is to improve the explainability and accessibility of AI models. On the accessibility side, we want to, as much as possible, continue releasing, new open source tools, for the community for free to bring more people, regardless of where they're at, regardless of, what resources they have, into the post AI world. I think this addresses what I would say the number one risk of this technology is, which is the sort of unequal access element to it. Like the version of the world that I fear most is like there's 2 or 3 mega companies that like lock everything down in like the early days, and so the sort of like, I don't want to say inequality necessarily, but the inequality induced by that only gets worse and worse and worse. That I think is like the number one future we have to be like watching out for. And then the explainability side of things really is, I think, Atlas. I cannot emphasize deeply enough how important looking at and understanding your model inputs and outputs are, for actually building models that are safe and doing the sorts of things that you intend them to do.
Cool. Awesome. So to close on a kind of a light note, one of the cool things, seen from my perspective as a New York-based VC, is that you guys are building the company largely out of New York, and I'm curious about your experience doing that. Like, obviously, there is there are like awesome things happening in San Francisco, the whole like Cerebral Valley thing. There's a little bit of a dominant narrative that AI can only happen there, which I find, depending on the day, amusing or irritating. And I'm curious what your take is and what your experience is as a New York AI startup.
The New York AI ecosystem is incredible. It's definitely, smaller than the Bay, but I think that gives it a level of like tight-knittedness that you almost lack in the Bay. And as someone that's sort of like been a part of both, like I spent a good amount of time living on Steiner Street in Hayes Valley, and I've spent, the last couple of years living here in New York. I think I prefer New York. And the main reason being, I think the challenge with Hayes Valley is in the sort of like Cerebral Valley and now the arena, is that it can get a little bit like, I don't want to say group thinking necessarily, but there is a dominant narrative. And it's like, I think when you're surrounded by that, quite hard to kind of like think a little bit outside of that box. And one of the things that I love about New York is you're not just surrounded by tech, like you're surrounded by incredible people in all walks of life, be it like, art or acrobatics or companies that are, doing things that are not necessarily AI, but up and coming. That aspect is really key. Plus we have sick AI heavy hitters in New York. Like Hugging Face has an office in Brooklyn, where's Hugging Face SF? Like it's not there, like, and especially as Paris, continues to be an up and comer in the scene, it's a faster flight from New York to Paris than it is from SF to Paris. So I think, if I were to bet on where like the global nexus necessarily would be, like if you're accounting for the fact that like, there are things happening outside of the US, I think New York is a very strong candidate.
Obviously, music to my ears, but like, I just don't think like all of this needs to be an either or. That's what I find a little much about the SF narrative. Is that SF is fantastic, and you can have fantastic things happening in different places. It doesn't need to like. Ultimately, we're all trying to build, or in my case, like finance, companies that are largely going in the same direction across the world. Anyway, rah New York, I appreciate it. Cool. All right, so time to talk about you're hiring, I'm sure. What kind of roles? How do people find you? How do they find you online? Like all those good things.
Yeah, you can follow us at Twitter at Nomic_AI. We are always hiring for particularly interesting people, is how I would describe it. I think everyone at Nomic is not only excellent at their sort of like work craft, but every single person has sort of like this interesting kind of +1 to them. So I know Zach hates it when I mention this, but for Zach, it's like not only is he an excellent machine learning engineer that can kind of single-handedly like drive a project to open source something as good as one of the top companies in the world, but he also played D1 baseball, right? Like it's that little extra something that I think really interests me.
Yeah, no big deal.
And also we hire a lot out of open source. And so if people want to get involved, like, we hired Zach out of open source, a couple of people that we picked up during the big hiring spree after we raised our A, Adam, Aaron, Jared, these are all people that had interacted with us on open source in Discord before, not necessarily like before it was cool, but like, we saw them like shipping and giving back to the community. And that's something that I think is really, baked into what we want to do here at Nomic. And so if you want to, work with us, like hit our Discord, come work with us, like, and we'll see what we can do.
And do you find that there is any difference between people that come from the prior world in AI and have done, I guess, what on some day of November 2022 became overnight classic AI or classical AI? Or do you need like generative AI native folks, or is that an irrelevant question?
It's a false dichotomy. Yeah, okay. It's a false dichotomy. You need all the above, and it's questionable if that's even like a distinction that should be made.
I've heard it made. Okay, but that's interesting and reassuring. Okay, awesome. This was super great. I really appreciate you guys' time today. Again, I appreciate that you chose the Mad Podcast today to talk about the new announcement, and congratulations on Nomic Embed, and excited to see what you all build next.
Yeah, thanks for having us.
Thanks, Matt.
All right, thanks, guys.